So, flowcharts and pseudocode. If you haven't seen my previous video, I said I would go into it, and here we are. Alright, let's start off with some definitions. What is an algorithm? An algorithm is a simple set of instructions to solve a problem. And if we look at pseudocode, pseudocode is a simplified programming language similar to Python, and you'll normally be representing an algorithm in pseudocode or a flowchart. A flowchart is a visual representation of an algorithm showing a sequence of steps to solve a problem. So in flowcharts we use symbols, and in pseudocode we use something a bit similar to a programming language. Alright, so an example. So if we look at the image below, we can see that on the left it is Python and on the right it is more like pseudocode. So you can see it's quite similar with the actual wording, but we don't have to worry about brackets and colons and things like that. And that's essentially is what syntax is. It's the rules that we have to follow when programming in a certain language. So you see Python, you're going to need those brackets, and you're going to need those double equals and those division signs and things like that. Whereas in pseudocode, there's no real rule, and as long as it's legible, you can kind of get away with it. Okay, and a flowchart. Let's look at the symbols and meanings that this is. So if we have an oval at the beginning, that generally means start and stop, or start and end, and we're going to need these at the top and the bottom of our flowchart. Arrows are to control the direction of flow, so you can look at the diagram and see which way we're going to be going throughout the route of the diagram. Next up, input and output. We use parallelograms for this. And an example of this could be if we're asking the user for an input, we can use a parallelogram. And also if we're going to print a statement or any kind of output of the program, we'd also use this. Right, simply enough, we have a rectangle next, and for a process, so if we're timesing two numbers maybe, or reassigning a variable, we can use this. Next up, we have a decision, which is indicated by a diamond, and this would use arrows pointing out of it. Specifically, you need two arrows coming out of a decision and one input. This could indicate an if statement, where the answers more or less have to be yes or no, or true or false, something like that. Alright, so an example of a flowchart, we're brushing teeth, and as we said, we always need to start and stop. So we're going to start off our flowchart with a start symbol, and then the process of getting the toothbrush and getting the toothpaste, then applying the toothpaste to the toothbrush, an input to insert the toothbrush into our mouth, and a process of brushing our teeth, and then we use the decision to see if the teeth are clean. If they are, we stop brushing our teeth, the program stops, and if not, we're going to have to loop back around and start brushing our teeth again until this is done. So we can see this is a loop, an iterative loop, to just keep brushing teeth until they're clean. Alright, now let's look at the pseudocode for brushing teeth. So first of all, whenever we are creating a function, we're going to need to write function plus the function name, in this case brushing teeth, and then we're going to use iteration or a while loop to check whether our teeth are clean, and if they are, we'll exit the loop and maybe rinse our mouth. Otherwise, we're going to keep brushing until they are indeed clean. So you can see that we've inserted the toothbrush into our mouth, then moved on to that while loop. Iteration is used to stop us having to repeat ourselves, because you can imagine if you kept brushing your teeth and not clean, you're going to have to write many lines of code for this. But a loop helps us do this all in a very small amount. Alright, understanding subroutines and functions. The subroutine is a set of instructions with no output, whereas a function is a set of instructions that do return an output. This could mean if you are doing an algorithm and it prints something, this is essentially a function, and if there's no kind of print message or anything like that, it would be a subroutine. So they're used in programs to stop you having to repeat yourself, and we can see that instead of having to write the whole algorithm or a whole function for rinse mouth, we can just call the function which we have written earlier and then apply it in many situations with just saying rinse mouth instead of having to write all that out on the right of it. In the photo, we can see that rinse mouth would have all this start to stop steps inside itself. All right, thank you for watching. Hope this has helped, and I'll see you again next time.